All right, this is Mr. Wyrick, and I'll be talking to you today about Lesson 2.8. That is the 8th lesson from Chapter 2, and the last lesson from Chapter 2. This goes into what we've been talking about with proofs, and today we are proving angle relationships. There's a lot of different stuff to talk about here. There's a lot of stuff to cover. It would be in your best interest to make a cheat sheet from this kind of stuff, and I'm just going to go ahead and say it. You should take these things down in your notes. The repetition will do you good, and understanding where you're coming from on this is going to be key to moving forward. A lot of these we're going to see again as we start proving lines parallel and triangles congruent. So these are going to come back again and again and again through the course of this class. First off, the postulates 210 and 211, the protractor. With the protractor, postulate 210 just means you can measure an angle using a protractor if you have one of the angles at 0, or one of the rays forming the angle at 0, the other ray at another one. You should be able to look at a protractor and assign that a value somewhere between 0 and 180. We're not going to deal with angles above 180 because when you start to go above 180, really you can just call it the other. Okay, we know all the way around a circle is 360, so if we did 270, we don't need a 270 degree angle because that would leave us a smaller angle of 90. So we would just assign 90 to the small side and understand that the other side is 270. So it's kind of useless really to go over 180. That's why the protractors don't do it. Okay? 211 is the addition postulate, which is basically if this is angle X and this is angle Y, then the whole thing would be angle X plus angle Y. It's fairly straightforward, just like the math that we were doing, the algebraic proofs, but it's something that you have to reference. A lot of geometry is, why is this okay? Why are we allowed to say that? Why can we do this? So geometry is all about saying this is why we can do this. A lot of theorems here. 2.3 supplement, so two angles that form 180 degrees or add up to 180 degrees are supplemental no matter where they are located. Usually it's a linear pair, but it does not have to be. 2,4 would be complement. Two angles add up to 90 degrees. Again, no matter where they are, they don't have to be adjacent, they don't have to be next to each other. The reflexive, symmetric, and transitive properties are all part of 2.5, just like in mathematics. If angle 1 is equal to itself, that's the reflexive. The symmetric is if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. You can switch the order there. And then the transitive, this one's kind of important here. If angle 1 is equal to angle 2 and angle 2 is equal to angle 3, then angle 1 is equal to angle 3. And of course you can reverse that with the symmetric and say angle 3 is congruent to angle 1. On 2.6 is congruent supplements. If two angles are both supplements of a third angle, then they are congruent. It kind of has to do with how your vertical angles are drawn, or when you have two lines crossing, the way that they fit together. Same thing here with congruent complements. If two angles are complements with the same angle, they are congruent. It can also be flipped around. If two angles are congruent, then they will both be complementary to the same angle. 2.8 is your vertical angles. Remember your vertical angles. If you make like an X here, the ones across that point from each other, no matter how we have that drawn, the ones across the point from one another are going to be congruent. It's something that you'll get to see as we get, especially into like this supplementary one. Okay, here's why they're the same thing. And then on page 155, I didn't even have room to write them all here. There's a lot of them about right angles. You're going to use those theorems, those postulates, just like we were using the stuff for the ones in the last couple days, and you are going to put together proofs saying this is this and this is this because of this. Okay? Again, you ask your parents about geometry, they'll tell you it's all about those proofs, those two-column proofs. They'll remember doing it. They won't remember all the different postulates and laws and rules and things. They could probably tell you CP, CTC, but not really remember what it means. So understand we're going to be working with proofs a lot this year as we move forward. Our next lesson is actually going to be a lesson over Chapter 3. Make sure you get this stuff finished up, and any questions, make sure to bring them to class. We'll see you then.